Hello friends, the next topic now is a fibrinolytic agent, or these are also called as a thrombolytic agents. The learning outcomes on completion of these sessions, the learners will be able to define and describe the fibrinolytics, role of fibrinolytics in the human body, what is the role of the fibrinolysis mechanism, then what is the requirement of these fibrinolytic drugs that we will discuss, and what are the agents and their mechanisms of the fibrinolytic agents. What are the agents which are used as a fibrinolytic agents? What is the role, what is the requirement, and what are the pharmacotherapy of it? Now, fibrinolytics, it is also, as we have previously seen, it is also known as thrombolytic. Now, these are the agents which dissolves the already formed thrombus. These are not like that they will prevent the formation of thrombus. They digest the already formed thrombus. So, warfarin, heparin or selective 10A inhibitors, these are the also have their limited property as thrombolytic agents. Okay, so actually warfarin, heparin, these are anticoagulants, but up to a small extent they also have the digestion property for the thrombin. So thrombolytics are used to facilitate the lysis of already formed clot. Those who are formed clot, they will be lysed, they will be digested. So they act by converting the inactive zymogen enzymes plasminogen to the active protease, protein digesting enzyme, that is plasmin. Plasmin is a protein digesting enzyme. So plasmin, it is a non-specific protease. They catalyzes, protease means catalyzes the proteins, and they digest the fibrin. So already fibrin thread, clot means that it's actually the formation of fibrin thread. So this fibrin thread will be digested by the plasmin, which is activated for activate form of a plasminogen with the help of zymogens. So fibrins are converted to fibrin degradation product by the fibrinolytic agents. So example of those drugs which are specifically used as a fibrinolytic are streptokinase and urokinase. Up to a certain extent, the anticoagulant also possesses this kind of a property. The very first agent amongst them is the streptokinase. It is a protein which is produced by beta hemolytic streptococci. It is one of the protein which is secreted by the streptococci. It forms a 1:1 complex with the plasminogen. Complexation, streptokinase form a complex with the plasminogen, 1:1 complex, and it converts the inactive plasminogen to active plasmin. Plasmin is a proteolytic enzyme, we have already seen in the previous slide. So it converts the plasminogen to active plasmin. Then this plasmin act as a thrombolytic agent. It is a foreign protein. So for our body, this streptokinase is a foreign protein. So it does also have the capability to produce the antigen type of reaction, antigenic type of reactions. So streptokinase may produce the antigenic type of reactions inside our body. Moreover, the thrombolytic actions of the streptokinase is completely non-specific. It also causes systemic thrombosis, fibrinolysis, and leading to the bleeding. So many times this fibrinogen to fibrin conversion is essential in our body so as to prevent the bleeding. So it produces a non-specific thrombolysis. So all over body the thrombus formation will be stopped. So thrombolysis, whatever the small clots which are necessary in our body, they are also dissolved over there, and this is leading to the bleeding property. So this is one of the non-specific thrombolytic agent. This is one limitation of it. So it also approved for the treatment of ST elevation, one of the cardiovascular disorder, myocardial infarction, and pulmonary embolism. These are the conditions where they are specifically prescribed, they are specifically approved and used. And the half-life is 83 minutes, one of the feature of the streptokinase. So the other drugs from this category is urokinase, which is produced by human neonatal kidney cells. Neonatal kidney cells produces this urokinase, and later on it is available as a lyophilized powder and reconstituted and diluted before the use. The typical feature is that half-life is only 7 to 19 minutes and duration of action is almost around 4 hours. It also possesses the same mechanism, that is conversion of plasminogen to active plasmin, and this plasmin then digests the fibrils, that is nothing but the clot. Now the streptokinase and all other related drugs, these are the life-saving drug, because most of the time in angina pectoris or myocardial infarctions there is a formation of a clot, and that clot is entangled at some blood vessels and it will block that coronary artery or some artery or vein inside the brain also, and it prevent the supply of that oxygen to vital nutrients, and at that time that breakage or breaking of the dissolution of that clot is very important. And this urokinase and streptokinase plays a life-saving role. They digest that clot, and the thrombotic disorders like pulmonary embolism, deep venous thrombosis, several lower extremity edema, they can be overcome by using these agents. So these are, most of the time, these are the life-saving drugs. So fibrinolytic act as a first line treatment. It is a very first line treatment in most of the acute myocardial infarctions also. So these are the, in short, the drugs which are used as a fibrinolytic agent. If you have any problem, you may contact me on a given contacts. Thank you very much.